Robot plugins are introduced into Sugarcoat and EMOS in order to seamlessly bridge your automation recipes with diverse robot interfaces. When you create your robot automation recipes in ROS, you often have to deal with custom interfaces created by the robot manufacturers to handle either sending robot actions or for getting some low-level feedback from the robot, like odometry or battery information and so on. Now, if you are using traditional ROS2 packages, you will need to perform some code changes in order to handle each new interface type created for a specific robot, which creates a sort of a lock-in for your automation recipe. Now in Sugarcoat, these robot plugins act as the translation layer which sit between your Sugarcoat application and the robot's hardware with all of its custom interfaces, which allows you to write your automation recipe once using standard types, then switch robots or switch interfaces by simply changing the plugin that you are using. You can find a complete guide on how to create and how to use custom robot plugins by going to Sugarcoat documentation. We have also created an example robot plugin, which you can find on GitHub. So now we're going to test using the example plugin that we wrote, which we called My Robot Plugin, which defines a custom interface for getting odometry-like information from the robot, which we called custom odometry. And it also defines a custom service for sending velocity commands to the robot, which we called robot action call for sending twist-like commands for velocity in 2D. And we're going to test using this plugin with a navigation recipe from the Compass navigation stack, which was made for the TurtleBot 3 robot. So let's first start by running the test recipe without adding the plugin. So after following the installation instructions in the documentation of Compass, you can then run the recipe as it is by simply typing ROS2 run Compass TurtleBot 3 test. Then we can check the running nodes and topics by using the RQT graph utility from ROS. So ROS2 run RQT graph, and we can check all the nodes and topics that we have. So we can see that the navigation components are subscribed to an odometry topic, which is the standard nav messages odometry, and that the drive manager is publishing a CMD-vel topic, which is the topic for publishing twist commands. Now, after we have already built and sourced the workspace containing the custom robot plugin, we can enable using it in this recipe by simply going to the recipe script and adding the robot plugin in the launcher. So we give it the name myrobot_plugin, which is the package name. Now we're going to run the same recipe again. And we're going to run the RQT graph again to see the changes that we have in the nodes. So we can see now that all the components are subscribed to myrobot_odom topic instead of the odometry topic, and that the drive manager is no longer publishing a velocity command. Now, if we inspect the drive manager node further by doing ROS2 node info drive manager, we can see that a new service client got created, which has the type myrobot_plugin, the robot action client for sending the twist commands. And we can also see that now it's subscribed to the custom odometry topic, and it's no longer publishing the twist command because it would be sending the commands using the new custom service call instead. Et voila! This is how easy it was to use the custom robot plugins in order to create more general automation recipes that can be ported across different kinds of robots using ROS.